Hello and welcome to ML with AP. We'll continue with our playlist on Numpy. Today we are going to learn Numpy aggregations, how aggregation functions work on Numpy arrays. We are going to see that in detail. Let's learn. First thing first, we'll start with importing the Numpy as NP. The second, what I am trying to do over here is we are trying to create a sample or just a toy data set for an L array, right? What I'm doing is the arange function. So arange function, you pretty much know that it will start from 0 and go till all the way till 9, right? So I need 10 elements. I need to stop it at 10, but not at 10 before 10, right? That's what arange means. Let's do that. This is 0 to 9, 10 elements, perfectly fine. What I will do is I'll do a sum of L. Now here, friends, I have not mentioned np.sum. That means this is Python base function sum L, right? I'm doing a summation of L. Give me 45. All the sums becomes 45. Aggregate works beautifully. Now let me do the np.sum L. Now I'm using the numpy provided function on sum 45. Perfect. Which one would be faster? Now by now, if you have seen my previous video, you already know the answer. Numpy is always faster than the base Python. Okay, let's try to see how that works. Okay. Now what I'm doing is that instead of 10, to see the difference in timing, I will create a big range. Okay, so my range is like how many zeros are there. Let me do just this. Okay, so Python understands this underscores and it is 1 million, like 3 zeros and 3 zeros, it is 1 million. So I'm creating a record of 1 million, an array of 1 million, right? And from 0 to like 99999, right? And what I'm doing is I'm executing both the sums, the Python native as well as NumPy sum. Let's see the timings. Okay, the timing is going to come now. Yeah. So the Python native took 66.1 milliseconds. Let's see what the NumPy sum took. NumPy sum took 127 microseconds. Again, a factor of 1000 over here, right? So it's almost like a 1000 or 500 times faster, right? Which you can see over here. Okay. Now, why it is faster? By now you must be knowing it runs on compiled code, broadcasting, vectorization, C versus Python, all those things, right? Which you have already discussed in the previous videos. That's why NumPy is super fast. Okay, now the other kind of, one thing is sum, the other kind of NumPy aggregate functions are maximum and minimum. Let's see, the minimum and the maximum, right? You can execute it natively also. You can use the native Python function. You can use np.min and np.max also, right? That is also there. Again, for the same thing, I have executed np.min on the base and this thing on the numpy function. Let's see the difference. Again, the difference is in millisecond and microseconds, right? Same thing. Okay, so min, max, sum, several other numpy aggregate. A shorter syntax is to use the methods of the array object itself, right? What does it mean? Let's see. In the previous videos also I have discussed with this dir, right? Through dir you can see that what are the object attributes and the function or methods which are available to a particular object class, right? So for big array is my numpy array, these are the attributes and functions which are available. Okay, now if you notice over here, and let me show you. Okay, min is also available over here, right? That means min is, first of all, we need to know that whether min is an attribute or a method. We'll talk that about in a minute. But first thing that, okay, min is something which is exposed through, I can use it as a dot, right? Operator. With a dot operator I can use. So this is my big array. It exposes attribute or method, I do not know, but I can access that with a dot operator. So when I access that with a dot operator, let me put this min, because since I know it's a callable or it's a method or a function, I'll put you have to put two parentheses over here, right? And when I did a min of this, I got a 0. The same thing as min of this, right? So there is actually no, there are three ways to calculate if you see, right? Big array min. So what I'm doing, I'm calling the method on the object itself. Here I'm using numpy's min function. Here I'm using not NumPy. Let me just show you the min, the Python's min, right? I'm doing this. All three are giving the same results. This one will be the slowest, the Python native one. This and these two things are actually the same, right? These two will not be different. They're actually the same. It's just that which way you are comfortable writing it, in which way the readability is more. Some people use it like this, npmin. Some people use the native methods, okay? Or the methods which is exposed as a type of the object, right? Similarly for max you can do, and if you do the BigQuery min over here on this is also in microsecond, 416 microsecond. How much it took? 416 microseconds, right? When we execute it in this format, right? Exactly the same thing, okay? Now, as I was saying this, I was telling you that how to identify attributes versus methods, right? These are all dunders, right? These are all dunders, right? So what I'm doing is I'm writing a list comprehension. What essentially it is doing, it is trying to check whether the get attribute. So I'm getting one attribute at a time. If it is callable, that means it's a function or a method, right? If it's not callable, it's an attribute, right? So that's what I'm doing, and then I'm printing it. So all our, if you see the dunders one, are functions, right? If you come down over here, right, then there are attributes and methods both. Attributes and method both, okay? So like dot, which we have already seen, right? Or max and min we are seeing, right? These were functions. So I was saying that you have to supply double parenthesis. If you do not supply double parenthesis, it will not give you the result, because this is a function, this is a method, right? So you need to specify this for it to be called, okay? But in case of attribute, let's say endim, if I endim is a attribute, so it's a feature, right? It will just, I do not need to put these two things. If I put those two things, it will throw an error because it's not callable, it's not a method, okay? Understood? Okay, let me just remove that over here. Okay, okay, yeah, these are the things, okay? Now endim, again I was saying that endim, this will throw error, right? Method, these are the methods, so you have to specify parentheses, right? Because these are callable functions, okay? Now these are your internal ones, you are not supposed to use it, but how Python internally does it is also we can show it to you. So the way to show that is be your, let's say you want to do the addition. How you will do the addition of 1? Normally you will do big underscore array plus 1, right? This thing you will normally do. This thing gets implemented in Python using this, right? So it has a dunder function. If you see add, okay, so you, with the dot operator, you get this method or function and you supply the argument over there, and this implements, right? So this is how internally it is implemented. We should not be using these internal methods anyway, right? Methods are functions callable, need to access with dot and then parenthesis. Attributes are stored values. They're just values or feature or characteristic. We do not need to provide parentheses. These are the key takeaways. Okay. Now let's see over here. Most of these utilities in NumPy are exposed both as functions and methods. Okay. Now what we are calling functions and methods interchangeably, but there is a slight difference, subtle difference over there also. And the difference is that you can call it like min np.min big array, right? Or you can call your like this. You can call this. What is the difference between the first and the second one, right? The first one is a function which NumPy provides. How internally it implements, that's also using this only, but overall we have a higher level function or API which is provided by NumPy, which can do a min operation, not just on a scalar, it can do on all the other things, right? It can do on an array also, right? So over here we are passing an array and we are trying to get the min value through NumPy base min function. The other way to do it is that this particular object has a method which is exposed because this is an object of array class as a min method also. So we can call it this also. So this usually is called method of the object, right? And this usually we call it function of numpy, right? So this is the subtle difference between function and methods over there, right? And what will be the attributes? Attributes which are non-callable, right? Which is exposed as a part of the object because of the object. Like if you have to do big underscore query dot endim, right? This will be your attribute of the object, right? Which object? Array class, big array, right? Array class object. So friends, you know the difference between function, methods, and attribute. This is important. Please keep that in mind. Okay. Multi-dimensional aggregates. You can do the same aggregation on multi-dimensional also, right? So I've created what an M of 2 dimensions, right? When I run the sum, it gives me a scalar quantity, sum everything, right? It will do the sum everything. Okay. Similarly, I can do np.sum also using np, same thing, right? m.min axis 0. If I can run min also because it's a 2-dimensional. If I provide the axis, what is axis 0? Axis 0 is columns, right? Remember, this was axis 0, this is axis 1, right? We have talked about that. Axis 0, then it will do the minimum column wise, right? So first column has 0, second column has a minimum 1, second column 2, and third, and so on and so forth, right? Similarly, if I switch the axis for the max, now the axis become this one, right? So for this, what is the maximum value? 3. What is the maximum value for this? 7. What is the maximum value for this? 11. So 3, 7, 11. Got it? N.sum axis.0. Again, if you provide the axis, it will do on that particular axis. If you do not provide the axis, it will do aggregate completely, right? So these are the aggregation function, np.sum, np.prod, np.mean, and all those things. One thing, friends, to note over here, and let me show you that by an example first. Okay. Now, what I'm doing is, let me just show you over here also. First thing is I'm defining an M array. Okay, no problem, right? This is M. Okay, 0, 1, 2. Now I'm setting this M0. What I'm doing is I'm setting this M0 as np.nan. Nan is not a number. It's a special thing which is the absence of any number, right? Nan. This is represented as nan in NumPy or in Python generally. I'm setting the 0 index, this as nan, right? I set it, I executed. Now the first is absence of a number, right? Nothing is present. Nan, not a number, right? Let's see what happens if I try to do that with I try to run a sum operation on an array which has nan present inside that. Okay, let me do normal function call. So I'm running np.sum m. What is the aggregate? Aggregate is coming none. It should aggregate these, right, which are my float, but it didn't do that. Once nan is there, it aggregated that, okay, I do not, it is undefined, I do not know what it is, right? So NumPy also provides you the nan safe versions, right? These are more recent, but these are the nan safe versions. So if you see in your data array, if you have nan values, then rather than using this, what you should use is this nan safe functions. So for aggregation, you can use nan safe, right, like this. When you execute this, the nan safe function called nan sum, it gives you 45. Why 45? Because this is 45, right? The sum of these is 45. Okay. Now let me do this. Okay. If I do something like this, right? I did np.nansum, right, over here. If I do m.nansum, will it work? I'm using a method, not a NumPy function, but I'm using a method, friends. Will it work? It will throw an error. Why it is throwing an error? It is showing that this object doesn't have an attribute or a method which is nansum. Over here, if you see, let's go to n. 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 These are n. Do you see a nansum over here? No. We see max, min, min, but nansum is not there. So all the Python functions are not exposed as an attribute or a method inside that particular object class, right? So that's why this is throwing the error. Okay, I friend, you like this video. I will close this video at this point. I will see you all in the next video. Thank you.